Now, typical representations of general vectors so that we can prove things about vectors, we can prove things about length, we can prove things about dot product and so forth. In R2, we just let V equal the ordered pair of V1, V2, or we could make brackets here with a comma or semicolon, or we could put it in a column, but we use V1 and V2 for the components of the vector V. Very simple notation. Or we could say in two dimensions V1I plus V2J. They all mean the same thing. In 3 dimensions, we could go V1I plus V2J plus V3K. Beyond 3 dimensions, we're not going to use letters for the unit vectors. We might use subscripts like vector E1, E2, E3. That's a typical notation for unit vectors and the directions of your coordinate axes in higher dimensions. So you could have up through E1 through E17 in R17. Okay. Now, in Rn, which could be R3, R17, R47, R2, could be anything, we can generally write the vector as, first of all, just an ordered n-tuple. And sometimes we'll put a vi minus 1 and a vi minus 2 somewhere in the middle to indicate a typical vector or typical component. But a lot of times we don't really need to do that. Sometimes it's a very good idea. Or once we get used to this, and once we're sure our readers are used to it, we just write V1, comma, dot, 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 comma, Vn. Indicating, we understand there's a V2 and a V3 all the way up to Vn, whatever n is. Well, once we have this notation, it's really easy to do some simple proofs. So let me just give you a quick example.